Hello and welcome to ICMR NI's online course on causal inference from observational studies, NICER 201. In this topic, I will be talking about logic and logistics of cohort studies. I will be covering this topic in 5 sessions: design and selection of study population, types of cohort studies, exposure and outcome ascertainment, finally, strength and limitations of cohort studies. In the first session, I will talk about the overview of cohort study design. The term cohort is derived from the military. A cohort was a 300 to 600 man unit in the Roman army. 10 cohorts formed a legion. In epidemiology, the word cohort describes a group of individuals sharing common characteristics. It could be people living in a city, workers in a factory, or students enrolled on a course. In cohort studies, we follow a group of individuals over a period of time. Cohort study has many synonyms such as incidence, longitudinal, forward looking, or follow up, concurrent, or prospective study. All these terms are same. Temporality is one of the key criteria we apply while evaluating causal relationship. For a relationship to be causal, exposure must precede the outcome. In cohort studies, we typically start with the exposure and assess outcome during the follow-up. We can examine this temporal relationship between exposure and outcome only in cohort studies. Cohort studies can be descriptive or analytical. In descriptive cohort studies, we will follow only one group over time with the objective of estimating incidence. Whereas in analytical cohort, two or more groups are followed to compare the incidence in different groups. We can study causal relationships only in analytical cohort studies. In a cohort study, we select a group of exposed individuals and a group of unexposed individuals. We follow both the groups over a period of time. During the follow up, we identify people who are diseased or not diseased in each group, and then we calculate and compare the incidence between exposed and unexposed cohorts. In this illustration, only two groups are shown, but we can also have more than two groups. For example, it could be categorized as no exposure, low exposure, and high exposure. The basic requirement for enrolling in a cohort is that they should be at risk of developing a specific disease we are investigating. This is often described as the population at risk. At the beginning of the cohort study, while enrolling participants, we should ensure they are free from the disease under investigation. For example, if the disease under investigation is cardiovascular disease, we need to ensure all the participants enrolled in both the groups are free from cardiovascular disease at the start of the study. For diseases which occur only once, it will be straightforward to exclude them at the start of the study. We are very clear that death can occur only once. For incurable diseases like diabetes, the disease can occur only once. But some diseases may be recurrent, for example, urinary tract infection. In this case, being part of a population at risk is a dynamic process. A person is not part of the population at risk when he has an UTI, and after recovery, the person can become a part of population at risk. If the focus of the cohort study is to investigate uncommon risk, we prefer special exposure cohorts. For example, we can have occupational cohorts or survivors of bombing of Hiroshima and Nagasaki. But if you are planning to investigate any common exposures like air pollution or smoking, we prefer general population cohorts. Example, Framingham cohort study. We need to consider two important points while selecting the comparison group in a cohort study. First, the unexposed or less exposed comparison group should be as similar as possible with respect to possible confounding factors. Second, the information collected should be as accurate and as comparable as possible in all groups in order to avoid bias. We could have three types of comparison groups for cohort studies. And internal, we can have internal comparison group, external comparison group, or a general population as comparison group. In a cohort study with internal comparison group, we select the unexposed members from the same cohort. Internal comparison is considered as the best comparison group because the participants are likely to be similar. For example, in British doctor study, both smokers and non-smokers were from British Medical Council. Whereas if a cohort is homogeneous in terms of exposure to a suspected factor, like that is all the individuals in the group are exposed, we need to look for a similar but unexposed cohort externally. This we call it as external comparison group. For example, the investigators wanted to study the cardiovascular effects of carbon disulfide among viscose rayon workers. So, in the study, the unexposed workers were chosen from metal, plastic, textile, or starch processing industries. So, that is an external comparison group. Alternatively, we can also take the general population of the geographical area where exposed individuals live as an external comparison group. If you are not sure that any single group will be similar to the exposed group in terms of the distribution of potential confounding variables, it will be useful to have many comparison groups. For example, a cohort study set up to examine cause-specific mortality of workers in a tire manufacturing plant in Ohio had three comparison groups. The first comparison group is industrial cohort of steel workers. They took steel workers as the first comparison group, and the population of the Ohio state as the second comparison group, and the US national population as the third comparison group. To sum up, in this session we have seen what is a cohort study, what are the principles behind the cohort study, and I also talked about the overview of the cohort study design and what are the key considerations we have to keep in mind while assembling a cohort. Thank you. See you in the next session on types of cohort studies.